Yeah, we're gonna revise today area between two curves and partial fractions. So we're gonna pick here two questions and two questions from each topic and solve to remind you guys of what you have to study or the skill here. It's talking about area between two curves. So let's get started. The first, guys, the area of the shaded region in the figure below. What's the area in the shaded region in the figure below? So it's a time for asking, guys. So if you have any answer here for this question, you can tell me to start and answer with me. Yes, so guys, how to solve this question? It's given two curves, 12y squared minus 12y cubed and 2y squared minus 2y. So I started by this topic, guys, since we already finished the volume between volume of solids of revolutions by disks and washers. So this is the 5.1, and then we will revise partial fraction, and then trig substitution, and then by parts, and then by substitution, and then logarithms and exponential, and then integration. So here, as you see quickly, the right and the left function, we will write here.
Yes, I think
The
it's
right
right.
curve. Yes, the right
Right
minus
minus
left.
upper, right
Yeah.
minus left.
Yes, the area is equal to right function minus left function
From 0 to
with
1.
respect to y, dy.
Yes.
From what to what?
0
From
to
0 to 1 here. From 0, it's bounded between 0 and 1. The intersection points are clear, so no need, guys, to equate the two equations here. Also, the equations of the curves given in terms of y, and x equal, given x equal, so no need to solve for x. You only need to substitute in this formula. So to substitute in this formula, do you see it here? We will see the right function. We'll write the area equal the right function from 0 to 1. We negative the right function. The right function here, it's 12y squared, 12y squared minus 12y cubed minus, again, 2y squared, and here plus 2y. And you know why, because negative is positive, dy. Easy, easy. So let's integrate here, guys. Yes, let's integrate this all. So easy to integrate. We can combine like terms first and integrate. We can say that this can be written as from 0 to 1, and we can add the like terms, 12y squared and minus 2y squared. So 12y squared minus y squared is equal to, we have 12 minus 2, which is 10y squared. And then we have also here negative cube, no like terms, more than. So we can complete easily by letting a negative 12y cubed plus 2y dy. The integral step is to integrate here, guys, open brackets, 10, and then add 1 to the exponent and divide by the new exponent. So it's gonna be y to the power of 3 over 3, okay, minus 12 over 4, y to the power of 4 plus 2y squared, and this all over 2. I don't know why I'm talking like this, but still, 0 to 1 equal, and then substitute. Substitute by 1 only, guys. Why we will omit the 1? Because we have y in all terms. So substituting 0 gives 0. So no need to substitute 0. نبدأ always, guys, start by the upper limit of the integration, 1 for every y here. So we have 10 over 3, and then minus 3, because 12 over 4 is 3, and then plus 2 over 2 gives 1. And we know substituting 1 for any y here, y to the power of 2 to the power of 4 to the power of anything, it gives 1. And I'm waiting for the answer. 10 over 3 minus 3 plus 1, which is 10 over 3 minus 2. And minus 6 over 3. Okay? So minus 2 here. Yeah, so my answer is what? Is 4 over 3. which is letter A. My answer is letter A. Any question? This is how to find the area between two curves. لما يكون two curves واحد right واحد left. Yes, the next question. Prefer to add one page here because we may need here space to solve this question. To find the area of the shaded region in the figure below, imagine that you have to enclose the area. Yes, to enclose the area. So
We'll
you
do
should
it twice.
decide. Yes, or multiply by 2, right?
Yes, or multiply by 2.
Yeah, we will bring the area of one of them and multiply by 2 because both areas enclosed here, the shaded region shown in the figure, تحس إن هم symmetric about the y-axis. So we can find the area of مثلا the right part and then multiply it by 2 gives the area of the left part. Yes. So to find Mr. Ahmed Saeed, thank you for your you are active today. Thank you for your behavior
Yes.
today.
From
طيب A1 how to find its area. Upper and lower, okay? نتفق إن upper and lower. The upper curve will be this one, which is 2y squared, and we will write here upper, and the lower one here, this one, صح? Okay, this is the lower curve. So let's say, what's the limits of integration? From what number to what number here? The area is enclosed between 0 and 2. Between 0 and 2, easy. And we will write here upper curve minus lower curve. And dx طبعا. Upper minus lower dx. Right minus left dy. Okay, equal to the integral from 0 to 2. So let's say it's only one area and multiply by 2. The total area is 2 times the area of one of them. So the upper curve 2x squared. So the graph is given for you. So ما عندك حيرة هنا. أنت على طول بتعرف إن upper curve كذا والlower باينة خالص. يعني lower curve is what? X to the power of 4 plus 2x to the power of 2 dx. Easy. But take care here, guys, that I changed the sign of negative 2x squared because negative is positive. Yes. And then integrate. It's a simple kind of integration here. To integrate, we start by, we can add first, it's no need يعني. طيب 2x to the power of 2, its integral will be 2 over 3 x to the power of 3 minus 1 over 5 x to the power of 5, and you know this basic fact of integration by adding 1 to the exponent and dividing by the new number or the new exponent. 2 over 3 again, x to the power of 3, and then this from 0 to 2. We will not also substitute 0 لأن في 0 تحت خلاص gonna give us 0. So 2 into plug in 2 for every x here. We have 2 power 3, which is 8. 8 times 2 gives us 16 over 3. Firstly, we substitute 2 for x and multiply it by 2 over 3. And then minus 1 over 5 times 2 to the power of 5 is 32 over 5. And then plus again 16 over 3. You can do this in the calculator or adding this, add 16 and 16, 32 over 3 minus 32 over 5, and then multiply this all by 2. 2 gives us the total area, the area of the A1 and the A2. Okay, so the total area we said is equal to 2 multiplied by the area of any one of them. Okay. Nice.
Mr. I have a question, but
yes.
If can we use another way? If we
yes.
got the inverse of the two functions, can we take it in terms of y, yani dy, and integrate the area?
Yes, we can. Right and
it
left.
will have
yes.
the same answer. Yeah.
but you will
okay.
change the limits of integration. It will be from -1 to
Yes.
8. Yes, we can. Type complete here. This way is easy. Type 32 over 3 minus 32 over 5 times 2. Yes, calculator, guys, and tell me the answer to pick the correct choice. So this will be the same as any questions in the final exam. Okay.
128 over 15, Mr.
128 over 15. It's clear here that it's letter what? It's a letter C. Okay, so let's write the answer here. Thank you, Faris. Over 50. Okay. Okay, so we talk two examples like this in how to find the area between two curves. One more, or let us leave this. Yes. Yeah, who can solve number 5 here? I will leave this, guys. I will stop sharing, guys, and then I will pick another topic to revise. We will take 2 questions on another topic, okay? It's better.
Okay.
Yes, so here, guys, we have 7.5, integrating rational functions by partial fractions. Rational functions. Here is the basic factor, guys, that's called the linear factor rule for each factor. If it's linear in the denominator, we add a constant in the numerator. If you have ax plus b, like 3x plus 4, like x minus 7, like any linear factor. So we write a1 over the ax plus b. We can write a and b and c. So if it's repeated, Mr. So the same, no problem, okay? That I provide you by the table. Guys, of partial fraction decomposition. So let's try this one. How to evaluate 2x plus 4 over x cubed minus 2x squared. But I would like, guys, you to participate with me. I'd like to check your understanding. What should we do here? We have to factorize first, right? So to factorize such a question, we leave the numerator the same. I'm talking about the factorization of the denominator. خلينا ناخد x squared common factor. So we still have x minus 2. Okay. Easy. This partial fraction. Why partial fraction decomposition? Yes. Because it's a rational function. It's written as a fraction. And no way here, like parts or by substitution, by anything else, we will not be able to solve this question. So I will ask you only to evaluate. You should decide which way you have to use. So here it's partial fraction decomposition. Partial fraction decomposition. So let's say here, guys, what should we do next here? You should look at the denominator factors. We have 2 factors now. The first one is x squared, and the second one is what? The second one is x minus 2. So the first one is linear also. Yeah, no, mister, it's a quadratic. Oh, حبيبي, you can factorize it again as x and x. So that's why لما نيجي نكتب partial fraction decomposition بتاعنا هنكتب a over x plus b over x squared. Okay, because it's repeated. And then plus c over x minus 2.
Yes, I don't understand this part.
You didn't understand why it's a over x and b plus b over x squared. Look at the
why
table.
Not a over x squared at all plus b over x minus 2.
Yeah. شوف الرول. For each factor of the form ax plus b to the power of n, to the power of 2, to the power of 3, to the power of anything. The partial fraction decomposition contains the following sum of m partial fractions. a1 over نفسه ax plus b. It's linear. بعدين constant again a2 over ax plus b power 2, and so on. If it's repeated 5 times, we will continue until we write 8 sub 5 over x plus b to the power of 5 and so on. Okay? So that's
Okay.
why we put a over x and b over x squared, because the x squared is a linear factor, but it's repeated twice. But it's what? Repeated twice. Okay, let's continue here. What should we do next? We have to multiply the whole equation by, we should multiply the whole equation by what? By x squared x minus 2. So multiply the whole equation by x squared times x minus 2. And I mean that multiply all of them, all fractions here and here and here and here by x squared x minus 2. And the left side leaves behind 2x plus 4 and cancel the denominators out after multiplying by x squared x minus 2. Here gives a into x minus 2 plus b into x minus 2 only, and cancel out the x squared. And now here c into what, guys? X squared only, c x squared. Next step, I will try to find here mean a, b, c, the constants. Yes, who can find with me, guys, the constants? Easy step. If we let x here equal to, if we let x equals 2, Faris with me? If we
Yes,
let
sir.
x equals 2, yes. Why
Can you
exactly
repeat
2?
the previous step again?
Multiplying here this x minus x squared times x minus 2. When you put it here and multiply, what will happen here? You will cancel out x minus 2, right? And leaves
Yes.
behind the x squared مع c. Again, you should do it here also مع b, مع the second fraction. You will cancel x squared with x squared and leaves behind x minus 2. When you put it here like this, you will cancel x with x only and leaves behind the ax into x minus 2. When you put it also here, you will cancel it all and leaves only 2x plus 4. Thank you.
Okay.
Next step, my goal is to find a, b, and c. So to find these constants, I'm going to substitute 2 for every x here. Yeah, why? Because if you plug in 2 here, mister, yeah, gonna give us what? 0, and here gives 0. Okay, so easy now. So we have 2x, 2 into 2 plus 4 equals, this one will be a into 2 minus 2 plus b, yeah, into 2 minus 2. So I would like, guys, to make it easier, so you know how to substitute. So I will write directly what's the result. 2 times 2 plus 4 is what? It's 8, is equal to here 0 and here 0. Yes, and now 4c only. So this is the first equation, and easy now to find c, which is 2. C is 2. Easy. Next step, we can let what? X 0. If we let x 0, if we assume that x 0, yes, if we let x equal to 0, yeah, quickly. Substituting 0 up here in this equation gives 4, and equal, here gives 0, and here gives 0, and now in the middle we have the b. The b is negative 2b, and we can find the b equal negative 2. Nice, thanks. Still C, A. How to find the A? You can substitute here by the value of C you got in the first, and the value of B, and also by any value from your mind for X. Like let X equals 1. Okay, any other value for X than 0 and 2. And the value of B and C in the equation above here, in this equation. So substituting quickly here by 1 for x gives here 6. Gives 6 equal 1 minus 2 gives a negative 1 times 1 gives a negative a. Okay, and then substitute 1 here gives a negative 1 times b, which is negative 2, gives only 2. Right? Substituting 2 gives 4. Times 1 gives 4. So easy now to find a. A is 0, right? 2 plus 2 is the same as 6. So the A is what? Is 0. So after you find A, B, and C, you have to substitute in this step here, in this one, in this step. Yes. So we have, I'll make it smaller to write it again, or we can take a copy of it. Here, do you see this step? I will duplicate and I put a copy, and then I will put it here to substitute. With me, the integral of 2x plus 4 and this all over x squared into x minus 2 dx is equal to, the A is 0 over anything 0, so I will not write the first fraction. The B is what, guys? Negative 2. So we can write negative 2 and this all over x squared plus the C is 2. The C is 2 over x minus 2 dx. We can integrate this, guys, easily. Yes, nice. It's negative. Yes, 2 over x will be positive 2 over x. Right. And then 2 over x minus 2, it's 2 lim, absolute value of x minus 2 plus. So this is your final answer. This is your final answer. So this is the first question in partial fraction decomposition. Partial fraction decomposition. Right, Mr. If I have a question like number 1, x squared plus x minus 2, you should factorize it first like this. And then a over x minus 1 plus b over x plus 2, and then the same, the same steps. Okay. But in question number 3, who has the idea of this question, guys? When the numerator has a degree that's greater than the denominator. If we check that question اللي فات هنلاقي النوميريتور عنده degree of 1 والdenominator كان greater عنده degree of 3. المرة دي denominator has a degree of 3 and the denominator has a degree of 1. لازم, yes, correct, yes, we have to divide. You have to use long division first. X cubed plus x and this over x minus 1. Yes, it's so easy for grade here A. So the long division step, it's so easy right now. يلا شباب. First
طب
of
مثل
all,
ما بناخدهاش بالعكس ليه طيب؟
what بالعكس؟ How?
يعني like up, but يعني instead of A is the numerator and B is the numerator, we make them the denominator.
The problem here that you have x minus 1 as a common denominator for both x cubed and the x. That's why you would like to separate this fraction into the sum or difference of two fractions. So common denominator here for what? For this. Okay. No way like this, Mr. Ahmed.
Okay.
Okay, and no time to what? Okay. Like we will take x squared. X squared by x is what? X cubed. And x squared by 1 is what? Negative x squared. Change the signs, cancel. So we have x squared plus x. Then we pick another x. X by x is x squared. And x by negative 1 is negative x. And change the signs. And I think that we have zeros right now. So x squared plus x. So we can write now our answer as here. Listen carefully, guys. The quotient, which is x squared plus x dx plus, and this all we can write it as x squared plus x dx plus the remainder. No remainder here. 0. 0 over the divisor x minus 1 dx. So this all guys will be what? Cancelled out, equal 0. Okay, but in the first part, we have to integrate easily here. So no need to use partial fraction decomposition. Then we'll check again the log division. X squared by x, x cubed, x squared. cancel out x squared plus x, and if we put x, yes, easy. خلاص integrate عادي, so it's 1 over 3 x to the power of 3 plus 1 over 2 x to the power of 2 plus what? C, plus the C. Okay, so easy here. Question. Thank you. Yes, in this case, when you have, guys, when you have x squared plus x minus 2, leave it tomorrow, guys. We will come back tomorrow again, and we will revise partial fraction decomposition. So let me revise another topic. It's better. And tomorrow also we will revise the same questions من كل topic كده أحسن. Okay. Yes. So here a question, a quick revision for what partial for trig substitution. How to evaluate x squared over root x squared plus 9. So the x is equal to a tan theta. So why a tan theta? Because when we have this form, which is x squared or anything over root x squared plus 9. So we have to use a tan. And you can see here, guys, from this table, the first page. Yes, plus a squared plus x squared, use a tan theta. Use a tan theta. Okay, because it's a plus. We'll move again here to our question. Yes. Okay, so use 3 tan what theta. And then substitute in the question. Let's substitute and move step by step because we don't have time. It's the integral of, make a line like this. Every x will be 3 tan theta. So here it's a 9 tan squared theta. And in the denominator, we have 9 again, tan squared theta plus 9. I still have dx. I have to replace it. So I will differentiate here. Dx equal 3 sec squared theta. And we are now in the last 2 sessions in the year. 100%, you know that the derivative of tan is sec squared. So we will write here 3 sec squared theta. Now complete the integral of, in the denominator, 9 tan squared theta times 3 sec squared theta. Leave 9 and 3, don't say 27. And in the denominator, قلنا ناخد 9 common factor and let it to be outside the square root. So it's gonna be 3. And we still have only the square root of tan squared theta plus 1, which is the identity and the famous identity. We know the Pythagorean identity, tan squared theta plus 1 is equal to sec squared theta. So if we have sec squared theta underneath the square root, this will be outside the square root as sec only theta. In the numerator, still 9 tan squared theta, 3 sec squared theta. And then cross out the like factors. We will cancel the sec with the squared, we will cancel the 3 with the 3. And then we still have only, guys, what? The integral of 9, we write it as a constant outside the integral sign. And then what? Tan squared sec. Still have tan squared theta times sec theta, d theta. Okay, d theta, I forget it here. D theta, sorry. Okay, next step is to what? Think how to solve this question. We know that if we let u as sec, no. If we let u as sec, so the derivative will be sec tan. It's not correct. But we can think of what, guys, here? Of again the identity. We know that tan, what is tan? We know that tan squared theta plus 1 is equal to sec squared theta, okay? Theta. So we have now tan squared theta is equal to sec squared theta minus 1. So we can replace this one, tan squared theta, as sec squared theta minus 1 and leave sec theta right now. And then use distributive property. So we have 9 into sec cube theta minus sec theta d theta. Okay. Now, how to integrate sec cube theta? Yes, it has a rule. It has a rule. So I need here more space. What's the rule, guys? This is here identity. And we have another rule we have to know, and it's very, very important, integrating trigonometric functions. What's the integral, guys, of sec to the power of n x, for example, dx? Yes. Can tell me the rule, guys. It's a negative. We have it here. Yes, sec to the power of n, sec to the power of 3, like this. Sec to the power of n. Yes. Sec to the power of n, yes, equal 1 over n minus 1. I search it for the rule and I bring it here in front. And my mobile, you can do it, guys, no problem. 1 over n minus 1 and then 10 x times sec n minus 1 x and then plus n minus 2 over n minus 1 and the integral of sec n minus 2 of x dx. So this is especially only for sec cube. I bring it for only this part, sec cube. So we can say that it's equal to 9 and then into, yes, 1 over n minus 1 over 2 and then sec to the power of 2 theta and then 10 theta and then plus n minus 2, which is 1 over 2 again the integral of sec theta d theta minus the integral again of sec theta d theta, which is here. This one is here. Okay, and all this, guys, is for what? For tan to the power of 3, for this one, for tan to the power of 3. Finally, it's 9 into 1/2 sec squared theta 10 theta plus, we have now to add the like terms, half sec theta minus integral of sec theta. This simply is equal to, yes, correct, it's a negative half the integral of sec theta d theta. Yes, equal to 9 times half is 9 over 2 sec squared theta 10 theta minus 9 over 2. The integral of sec, yes, all of us know it, guys. The integral of sec is equal to, yes, it's a rule, ln absolute value of sec theta plus 10 theta, okay, and then plus the c. So this is our final answer, and you can search on this answer in your multiple choice. Thank you. And this is our first session, our revision session, and I still have 2 sessions tomorrow, inshallah. We will revise more about, guys, integration of exponential and logarithmic functions, integration by parts, integration by substitution, and we will revise volumes of revolution by Washers and Assalamu alaikum.